The climate has always changed and will continue to change. It has been much hotter than now, and it's also been much colder than now in the geologic past. The problem with the climate change of the past 150 years or so is that the world has warmed rapidly due to human activity, and that human-induced change is overriding natural variability. This video is a simple introduction to the basics of climate change. If you would like to delve deeper into the science, please watch my other videos, and I also encourage you to read the scientific literature, as well as summary reports such as the US National Climate Assessment Research Program and the IPCC assessment reports. We're going to use basic physics and common sense to understand climate change. The basic physical principle is if you add energy to a system, it will warm in temperature. Our planet receives all of its energy from the sun in the form of electromagnetic waves. We all know the sun is hot and it gives off energy, which then enters our atmosphere. Our planet absorbs about 70% of that energy and reflects about 30% back to space. Our planet has an energy budget just like you have a financial budget. The planet has incoming energy and outgoing energy, and these amounts of energy have to balance out. Otherwise, our planet would get continuously colder or continuously hotter. We'd either freeze or we'd burn up. It's an imbalance of incoming versus outgoing energy that causes our global climate to change. We know this to be the case as it has been observed in the geologic record through millions of years. We have ice ages when our planet's energy budget becomes negative, i.e. when the Earth gives off more energy than it retains, when places like New York City were covered in a sheet of ice. During this time, the world was 4 to 6 degrees Celsius colder than present, and the sea level would have been around 150 meters lower. And we have warm periods when our planet's energy budget is positive, i.e. when the Earth retains more energy than it gives off. And all of the world's ice melts, raising sea levels and inundating places like the state of Florida. During these times, the world was 5 to 8 degrees Celsius warmer than present, and the sea level was around 200 meters higher. That's basic physics that we can all understand. Now let's get back to that 70% of the sun's energy that we do absorb. If all of that 70% was emitted back to space, like the red arrow shown here, our planet would be very, very cold, around negative 18 degrees Celsius or 0 Fahrenheit, and we wouldn't be able to live on Earth. What keeps our planet warm enough for life to exist is actually the unique makeup of our atmosphere. Certain gases in our atmosphere trap some of the outgoing energy, and they send it back down towards the surface. They act like a big blanket, keeping us warm. These gases are greenhouse gases, and the major ones are water and carbon dioxide. We know how much energy greenhouse gases trap in our atmosphere through simple experiments that were first performed by John Tyndall in 1863, and his findings have yet to be disproven. If there were less greenhouse gases in our atmosphere, the blanket would be thinner, and more heat would escape to space, making the planet colder. Just as we know that having less greenhouse gases would make the planet colder, we also know that adding more greenhouse gases to our atmosphere makes the planet warmer. If there are more greenhouse gases up there, it's like the blanket is thicker, and more outgoing heat is radiated back down towards the surface. Burning fossil fuels produces carbon dioxide, and we can calculate how much our planet must warm as the concentration of carbon dioxide increases. Again, we've been able to calculate this since 1863. So now we know how much warming the additional carbon dioxide produced by burning of fossil fuels has caused, and what warming it will continue to cause for the rest of this century. Over the last 150 years, we have increased carbon dioxide in the atmosphere by around 40%, and the world has warmed by approximately 1 degree Celsius as a result. The concentration of carbon dioxide in the atmosphere is now higher than it has been for hundreds of thousands of years. Adding more carbon dioxide to the atmosphere will cause more warming. We don't know exactly how much more carbon dioxide will be added by all of the countries of the world through the rest of this century, but many suggest a doubling of carbon dioxide. This would cause a warming of around 3 degrees Celsius. The last time the Earth was that warm, the sea level was around 50 meters higher than present. What we can be sure of is that because of the basic physics of the Earth's energy budget, if more carbon dioxide is added, it will cause more warming. The only way to prevent more warming is to drastically reduce emissions of carbon dioxide from the burning of fossil fuels.